Hey guys, welcome back. This is Frank, and welcome to our IGCSE Cosi Chemistry revision videos. Our current unit is C5 Detective Chemistry, and today we're entering our last and final video of the unit, which is separation methods. So some separation methods. But before that, I'd like to talk a little bit about melting and boiling point as well. So it's kind of like both. But yeah. The reason why we can separate and purify different stuff is based on these general rules as well. So I'll just write it here, general rules. These are very important for us to remember. But anyway, so yeah, let's dive right into it. So before we start looking at some separation methods, it took me a really long time to prepare for this video because I had to draw all these diagrams, but okay. Let's take a look at these general rules. Alright, so for a pure solid, it should have a single fixed melting point, and an increase in impurity will decrease its melting point because solid is a very fixed structure and a very regular structure. The intermolecular pattern is very regular. But then, if you have some impurities inside it, it will kind of disrupt that very strong intermolecular force, making it more susceptible to like being separated. So that's why it would have a lower melting point. And for liquids, a pure liquid would have a single fixed boiling point, as you might have expected, but an increase in impurity would actually increase its boiling point because it brings in extra intermolecular force. So like in liquid there were some originally some intermolecular force happening between the molecules of a certain type of liquid, and then when you add something else to it, it would have it needs more force to break apart the molecules inside the mixture. So that's why the boiling point would increase because it needs more energy or more force to break apart. So that's our general rules. And after that, we can take a look at some of the most common separation methods, and they're also mentioned on the syllabus. So, filtration, crystallization, distillation, fractional distillation, and paper chromatography. And for paper chromatography, we've already talked about that last lesson, as you can see above. So go back and watch that video if you haven't. And we're just going to talk about some other separation and purification methods in today's video. So the first one is very straightforward. It's probably the most basic and the most important one, which is filtration. So this is used when you have an impure mixture of a solution or something else, or if you have like some residuals inside that mixture or that solution. If you are let's say making crystals of copper sulfate, and then you added a lot of copper oxide into the sulfuric acid solution, then you probably would need filtration to kind of get rid of that solid part, and that's what filtration is all about, really. Right here. So get solid. So separate. Let's try this like that. So I'll use a special color. So it would separate soluble solid and insoluble solid. Alright, so that also applies to excess or excess. So or I should write a slash. So if you have excess, then you would also need filtration to give you kind of that very pure filtrate or solution. So here are some of the key things that you need to know in filtration. So you have so-called the residual, which is what is left on the funnel. But actually, the basic apparatus is you need a flask of force to kind of accept that that filtrate, and you need a funnel and a filter paper. So you need something to filter it on, and then what is left on the filter paper is called the residual, and what is inside that flask is called the filtrate. Alright, so that's basically the label diagram for this one, and there's nothing much really. Just remember to draw a funnel and always draw filter paper, and never forget filter paper because it's very important. And yeah, I guess we can move on to our next one, which is crystallization. So this is a bit more complicated. This is used when, well, you have a soluble solid, I guess, and then you would like to obtain crystals. So usually in these situations, it's very clear, like it would say you would want to obtain crystals. So you will know when to use crystallization. So crystals. Yes, it's also sometimes called evaporation because it evaporates, but it could be a different method, so be careful about that. Crystallization is just for crystallizing. But anyway, basically what happens is that we probably have a soluble solid and we put solvent into that solid. So like in this case, it's probably water, and then we would gently burn the solution on the Bunsen burner, and I said gently burn because if you burn it too much, then it would just start forming. The crystals will just start forming, and it wouldn't be very ideal. And the reason is that we want to evaporate as much solvent or water in this case as possible, so that whatever is left is like mostly pure crystals, and it also takes less time for it to evaporate. Okay, so then we take it off the heat and we leave it cool for a couple of minutes, and we will pour it into a petri dish where we would put a wooden splint so that it provides a rough surface for crystals to grow on. And after a few days or maybe a few hours, depends, you would see very beautiful crystals. And in some cases, they would also ask you to wash the crystals at the end with cold water. This is to get rid of any excess water or solution or whatever on the crystal to make sure they're dry. And then also, we don't want to use hot water in this case because we don't want the crystals we obtained to kind of be dissolved again. So that's why we need to use wash gently with cold water. Alright, so that's basically it for crystallization. It's used for soluble solids and soluble, just soluble stuff. And it is used to obtain crystals, and it can be used with, let's say, copper sulfate, which is a very beautiful example. I love the color of copper sulfate. But anyway, moving on, we have distillation and fractional distillation. So these two guys are quite similar, but just to clarify, I have to say here, distillation is used between liquid and non-volatile solids. Well, actually, I should write it in two lines, just like what I did above. So liquid and non-volatile solid, or perhaps I should write it non-volatile solids and liquids and liquids. All right, and this I will change this label actually to just to make sure so that we don't get confused. Mixture. So this is kind of like our source. And yeah, basically this is the setup. So you have a distillation flask, and where you will put your non-volatile solid. Oh my, what happened there? I think it's, hang on. I think I might need to move this up here so it makes more sense. Alright, cool. So anyway, yeah, basically, this is what happens. Like you have a distillation flask and you have a thermometer to measure the temperature. This is for temperature control, very important. And you have a mixture of non-volatile solid and liquid. And I have to emphasize on non-volatile because if it's a volatile solid, you boil it and it kind of, oh, I forgot to write the source. And it has to be in, you have to heat it in some way. So I guess heat source. Maybe a Bunsen burner or something like that, and also for this one as well. All right. So you would heat it. Like if it, where were we? Okay, so if it is a volatile solid, if you heat it, it would well, because it's volatile, would probably evaporate, and then you wouldn't be able to separate the mixture of the solids and liquids. So yeah, this is the way this works is that you have like two uh, different substances mixed together, and when it reaches the boiling point of this liquid, it would kind of turn to gas, and then it would pass through this what we call a Liebig condenser. Um, I would like just remember it. Just remember like lie big, a big lie. But yeah, a Liebig condenser, where you would pass cold water in and cold water goes out here, and then you would circulate it kind of, so that this very hot gas that's being produced will cool down into liquid. And here we have a receiver. It's very important in your Liebig diagram. Always remember to include a receiver in distillations. It will receive the liquid that is being condensed, and there you have it. And for fractional distillation, it's very similar to the regular distillation, except it's used for to separate two liquids. So liquid and another liquid. All right. So this this can only be used if they have a high difference in um, in boiling point. So how this works is basically you control the temperature to a point where it reaches the boiling point of one liquid or one substance, but not the other, so that one hopefully one would get evaporated and turn to gas, and then here turn into liquid in this Liebig condenser. And the other would not. The other would go through these glass beads or some obstructions, so that it would kind of condense back into liquid. And because this neck is very long, this fractioning column is very long, the bottom would be much hotter than the top, so it will kind of go, nah, it's not hot enough, and then just go back. So it will kind of condense back into liquid and drop back again. So that's how you separate the impurities or just one liquid in general from another. And here again you have the receiver beaker and you have the heat source, so never forget to include those. And yeah, I think that's about it for today's video. Hope you guys enjoyed it, and yeah, we learned about how melting point and boiling point are for pure and impure substances, solids and liquids. We also learned about several separation methods, including filtration, crystallization, distillation, and fractional distillation, and when they are used. So I hope you found that helpful, and that would be the end of our C5 unit. So I'll probably start again with another physics unit, perhaps next week, or I'll start with another chemistry unit, depend. But yeah, I hope that helped you, and I'll see you guys in the next video. Bye!